Just a few more people coming in, stragglers. Give them a second. You sit down, thank you. Mr. Morris is late. Black Cross. Okay, good afternoon, ladies and gentlemen, and thank you for joining us today on our presentation on innovation in water treatment. So today, I want to introduce myself. I'm Neil Burdess, the CEO of the Commissioning Specialist Association. Sorry, I need to talk to the mic. 30 plus years experience in commissioning and water treatment, and I have seen it go wrong. I've seen water coming out of pipes like jelly, bacteria in there like you won't believe, and corrosion from the inside out, absolutely destroying systems. And being part of the process of sorting buildings out, office blocks from a simple 6-storey office block in Manchester, which took 6 years to clear the water treatment problems. So hopefully what we're going to be focusing on today is going to try and alleviate a bit of them issues if we get it right. So like I say, water treatment quality remains one of the biggest performance risks in building services. Today, we're going to be talking about chemical-free water treatment. And at the minute, it's gaining real traction in the industry as an alternative to traditional water treatment and chemical-based water treatment. We are seeing it coming on a few systems. I was talking to Chris this morning, just before. He's there in the audience. He's up on HMRC in Newcastle. Brilliant project, gone very well with a chemical-free water treatment method, which is good to see. And some of the existing buildings where they've fitted these systems and the water quality has really come round without the use of chemicals. So I'm a big believer in this. I've been part of this journey for the last 8 years. So today, we'll we'll start with what chemical-free water treatment actually means in practice, how it differs from conventional methods. Then we'll discuss why it's important during the design, commissioning and operation phases. We'll share insights from recent projects and talk about the real challenges and opportunities the industry faces. And finally, we'll look ahead at what's next for adoption and guidance. The panel today, thank you very much for these guys for agreeing to come along on the journey with us. We've got Chris Parsloe, who's the author of many publications on water treatment, water systems, water commissioning. Chris is also the chairman of the Closed Systems Control Association, that's the CSCA. And he'll bring us his technical foundations and latest industry guidance. We've got David Wilson from Multiplex, who's the Building Services Operation Lead, and he'll bring us a lot of practical on-site experience. And then we've got Paul McSoley, our technical expert, who'll do a bit of a deep technical discussion on the design and control considerations and what we should be doing at site level. Then encourage the audience, please, to take some notes and ask some questions later at the end. So I'm going to be introducing Chris Parsloe up to the stage next. But just before we do that, we want to really define what chemical-free water treatment means and what chemical-free means. And I've been told this a few times. It doesn't actually mean a system with no chemicals in it at all, because simple GCSE science teaches us that all metals contain and release chemicals. So when we're talking about sacrificial anodes and all that, they will release magnesium, which is a chemical. So these systems, even though the industry is going down the route of chemical-free, it means we are not bringing a load of drums of chemicals to site. We've had it delivered, so we're saving on environment. We're not dumping chemicals down drains. So it is better for the environment, for one thing, for sure. So if we can invite Chris to the stage, please. Sorry, I wanted to introduce the rest of the panel. Oh, no, I've done that. So Chris, yes, to the stage, please, and he'll give us some key insights on chemical-free water treatment. Thank you, Chris. You are up. I have already done the panel, sorry.
Thanks very much. Chris Parsloe from, today I'm representing the Closed System Control Association. I'm chairman that group. It's a trade association for water treatment specialists that are involved in closed systems, pre-com cleaning and water treatment. So I'm independent on this. I don't sell any of these products, so I sort of have an independent technical perspective, because we advise customers on different types of water treatment, and we advise them on different monitoring options. So this is my sort of understanding of the chemistry, the technology, and what's going on here. You've got guys in the audience who are involved in products who I'm sure will put me right if I do get any of the science wrong. But this is basically an engineer's perspective of exactly what it is we're talking about when people refer to chemical-free. Now, I've defined it as solutions that aim to minimize the use of liquid-dosed corrosion inhibitor and biocide chemicals. So it's the taking drums of chemicals to site, dosing them, testing for them, and maintaining them that is being avoided. You're having it's an alternative approach which doesn't use those things. The chemicals we use in systems, they're normally doing three things. You've got scale prevention, corrosion prevention, and prevention of bacteria, biofilm. So those are the three things we're normally aiming to do in any water treatment process. If you're going to go chemical-free, to make it chemical-free, you need ways of achieving those things without the use of dosed chemicals. So demineralization is a good way of avoiding scale, because you take the hardness salts out, then you avoid scale formation. Demineralization also helps you with bacteria, because you're removing many of the nutrients for bacteria. So demineralization is always a good start. Deoxygenation, to remove dissolved oxygen, is a good way of preventing corrosion. So if you can maintain low oxygen levels by removing oxygen, then you avoid the need for corrosion inhibitor chemicals. But also pH adjustment. You can't just put demineralized water in. You need to control pH to some extent, because that will also help you stifle corrosion. And wrapped up in all of that process is a general philosophy of preventing oxygen ingress. So you can't have a system that's freely allowing oxygen into the system if you're going to adopt this approach, because if you overwhelm the deoxygenation measures, then you will still potentially get corrosion. Is it this the button for that thing? So corrosion process, we all should be pretty aware of it from our school days. It's the process where, in the presence of oxygen and water, steel will form a corrosion cell, which will drive corrosion. And the two main products of that corrosion are magnetite, which is the black sludgy stuff that you get in radiators, and also rust, the stuff that we're all familiar with, the flaky brown stuff. So that's the corrosion process. If you put steel into oxygenated mains water from anywhere in the UK, it will corrode quite quickly. This is what some people don't grasp, how quick it is. If you go back and look in 24 hours, you start seeing the signs of corrosion. If you leave it a week without any form of treatment, you're then into quite a dirty system. So responses is one of the things we emphasize to maintenance contractors, is you do have to respond quite quickly. So that's the thing we're trying to prevent. But if you switch to deionized water by itself, or demineralized water, same thing. If you switch to that in itself is not a protection, because demineralized water can still have high oxygen levels. It's got lower conductivity, which means that should, in theory, it will give you some stifling of corrosion. But the trouble with demineralized water is it can dissolve carbon dioxide from the atmosphere, which can cause it to become acidic. And once it becomes acidic, then it will still drive corrosion. So demineralized water by itself is not a good prevention method. But if you control pH, so if you keep the pH up high enough, then it becomes a very effective method of controlling corrosion. You can see then that becomes And that's following basic chemistry of systems. If you keep the pH level high enough, then you're into this range between 8 and 10 or 11. Then you minimise the corrosion from the water. So a chemical-free solution, also known as an electrochemical water treatment solution, aims to achieve that, to drop the oxygen level but to control pH. So it does it by means of a reaction vessel. You pass a current through the water between your cathodic steel surfaces and a magnesium anode. The magnesium anode then dissolves, it corrodes, and as it corrodes, it absorbs oxygen that's passing through it, so that helps you to drop the oxygen level in the system. The magnesium hydroxide, which is the corrosion product of magnesium, some of that then dissolves into the water, and that's what raises the pH and gets you into the good pH range. So when people say it's chemical free, some would say, well, that's debatable because effectively you are adjusting the pH because you're putting magnesium hydroxide into the water. So it becomes a point of debate whether or not chemical free is the correct terminology. But as I say, the result is continuous oxygen consumption and an increase in the pH, and that's basically how it works. And that means you need to demineralize the water that you put into the system to begin with. You need to demineralize the makeup water, so you need extra demineralization plant on the cold feed into the system, and of course you need your reaction vessel with the magnesium anode. If all those things are in place, then you have a solution. Obviously, the suppliers of electrochemical equipment will, show you how that would work, help you specify the kit to achieve that. So there are some environmental benefits because you're no longer putting in chemicals which can be considered toxic to the environment. And although corrosion inhibitor chemicals, they're actually quite low percentages, but nevertheless you avoid the need for those nitrate or molybdate-based chemicals to go in at all. And also another benefit is the less need for biocides, because nitrite in particular has become, especially in London, has become a real problem in feeding bacteria. So you get systems that just constant problems, and often it's linked with the nitrite, because the nitrite, some of the nitrite, the bacteria live on the nitrite. So less need to dose with biocide. I wouldn't say necessarily 100% no need to you may still have systems that, if they're already contaminated, may still need some biocide, but certainly less need. But demineralized water comes with its own environmental issues. You're using chemicals to generate the demin water, and you've got plastic as a waste. So it's not necessarily a totally, environmentally friendly or neutral environmental effect. There is some environmental effect, but generally speaking, there are environmental benefits to it. In terms of operational benefits, as I mentioned, bacteria stability. And for any contractor trying to get a system over the line to BG80, BG29 requirements, it can often be a lot easier to get over the line because you avoid the need, you're not feeding the bacteria, so you can achieve those limits on TVCs and pseudomonads much easier. And generally speaking, there's probably less need for monitoring, ongoing monitoring of microbiological and chemical water quality parameters, because I think there's more stability from the systems we've looked at. You tend to get better stability of the values. But to implement an electrochemical solution, there is generally, if you look at the European guides, the German guides on this topic, and the Danish guides, there is a strong emphasis on prevention of oxygen ingress in the first place. So there's no 100% reliance on the magnesium anode to remove oxygen and keep it at low levels. There's a strong emphasis on designing the system to be oxygen impermeable from the outset. So that means looking at things like pressurization units and materials. I think Paul's going to talk about that in his talk. And also there is a general feeling, which is probably true for both of these things are true for chemical systems really, that corrosion monitoring is an important part of the process. So if you do have a situation where corrosion is occurring, you need early warning of that corrosion occurring. So corrosion monitoring tends to be recommended for these applications. It's not just, obviously, you know, to say, okay, you're going to go to a chemical-free electrochemical solution. There are other considerations. So how are you going to do the pre-com cleaning? What's going to be the maintenance, water treatment maintenance regime? And how you're going to deal with fit-out works and so on. And if you decide to switch from chemical to chemical-free, that also needs to be given some thought. Now, generally speaking, these things are manageable. Pre-com cleaning, you've got to have know that you've got a quite clean system to begin with, because you can do chemical-free cleaning, but not in a system that's already badly corroded or full of biofilm. So there needs to be a little bit of awareness on behalf of the contractor and the cleaning specialist to understand just what the state of the system is. You still need to sample and check that you're maintaining pH levels and maintaining bacteria levels and other key parameters, but probably no need for such frequent monitoring. Fit-out works, you can easily do a pre-com clean on fit-out works, but there may be a time element because sometimes you have to wait for things to stabilize a bit longer in a chemical-free option than in a chemical-based, if you're doing chemical cleaning. So there may be some time pressures to say, okay, well, maybe we speed things up by inhibiting using a passivating chemical, or you do some sort of chemical clean. So again, that just needs a little bit of thought as well about how you do that. And then converting from chemical to chemical-free, that's fine and feasible, but it's not a solution to a system that's already dirty and corroded and full of bacteria. So I don't think the suppliers would say this is a way to clean up a dirty system. Now, there is a guide already out there, which is CSA TM20, the Commissioning Specialist Association's guide, which is targeted at all of the key parties there, everybody. If you haven't got it, if you speak to Neil, is the man to ask if you can get hold of a copy. That's very good. It gives you a good understanding of the basics that I've been through today and also some of these issues. That's the main section headings. It talks about the various different guides and corrosion VDI guidelines, the German guidelines, and so on, and talk about implementation. And then also another good source of information is the organisation I'm here representing, which is the Closed System Control Association. And we've got events coming up on the 6th and 12th of November, where almost certainly this is going to be a topic that's going to be discussed and maybe even have a presentation about it. So that's the website for the CSCA. Heather, sitting in the front row here, can give you details if you want. It's a good association because all of the key service providers in terms of pre-com cleaning and maintenance water quality tend to be members and be there. They get audited and are companies that are sort of known by CSCA. And then finally, there's going to be a BESA guide as well. If you haven't heard, there will be a BESA guide on this coming out in, not sure, maybe January, February, which will again cover it and give advice for all of the parties, all sectors of the industry, on how to implement it and use it for different within different types of project. Brilliant. That's it from me.
Thank you, Chris. Over to Mr. Wilson next. David, thank you. He's going to give us some practical experiences.
Good afternoon all. David Wilson. So I'm one of the senior leadership team in building services within Multiplex Construction here in the UK. And I don't want to be that person who says I'm going to take you on a journey, but I'm going to take you on a journey. back in probably 2020, we all remember 2020, don't we? Because we're all sitting in our underpants in front of a screen in our house and Teams calls. And likewise, at that time, Multiplex, we had a point where a lot of jobs had stopped, some were continuing, but we used that as an opportunity to kind of consolidate. And part of the kind of challenge we were given by our CEO at the time was, like, what can we do as a business to make us, leaner, meaner, greener, all the sustainable innovations, what can we do to do that? So all of the heads of departments got that kind of challenge with their teams, and we went through that process. And one of the things, as Neil's talked about there, he talked about problems with pre-commissioning cleaning. And we are, we have lots of problems with pre-commissioning cleaning. And generally, it's because it's probably not been done right in some way, shape or form along the way. But it always causes a bit of a problem. I'm just going to put that forward. There we go. So that was one of the things in my mind. And one of the things we're looking at was the amount of water we pour down drains. So we pour, raw water flushing. We're pouring a lot of water down drains. How do we go about getting rid of that? And we started looking at the closed loop filterization filter methods to clean the systems up, which was the first thing. But one of our package managers had came to me and said, look, I've been looking into this a bit more, and we were looking at the chemical-free VDI 2035 out in Europe, used. He was just about embarking a project, which we'll come to in a second, and we started to look at that. And the more you look to that, the more interest, it kind of perked your interest. Okay, interest, well, nobody else seems to be doing it. What can we do with this to make it work for us at Multiplex? So we had a project which was 65 Davy Street, a project for Grosvenor. If you know the Elizabeth line, kind of West Bond Street Elizabeth line station, it basically sits right on top of that. We're already engaged with Briggs & Forrester at that stage, going through design verification, and we essentially were talking to them about this chemical-free VDI methodology. They brought on Reigate, who was going to be the pre-commissioning cleaning contractor. Reigate got involved, Paris from Reigate got involved. We started to look more into it, and we brought in a company called Alexian, who basically produced the equipment and understand the science, certainly way more than I did. So we brought them in, looked at it. In a business, we thought, we want to try and look if we can do this and promote this. But we thought, we'll try it. This is the job here, as I said down there, it was 2 air source heat pumps. It was about roughly 5,000 litres in the heating, 5.5 on the chilled. It was a reasonable size that we could cope with trying something new on. So we spoke to Arabs, who were the consultant on that job. We talked them through it. We brought Alexian in, who gave them the science on it, on the lot. We talked to them about it. They were quite interested in it. Again, a forward-thinking consultant. We then had to engage with the client, because obviously we do something different at this stage. That's a very small part in the life cycle of a building. They've got to operate and maintain that for the next 20, 30, 40 years, however that's going to be. So we brought them on board and talked to them through about it, and they were quite interested in it as well from a sustainability point of view, and, the buildings that were causing them problems post-handover, with chemical issues. So we pretty much got the buy-in off of these guys to move on with that. With Chesterfield's consultants were employed by Grosvenor as a kind of validation verification on the water treatment, and we took Chesterfield's through it as well. And again, a bit like me at the time, quite sceptical maybe a wee bit, but thought worth trying. And they pretty much shadowed us through the process. So it was a 65,000 square metre commercial development. We were doing shell and core and the Cat A fit out. So the method, we've talked there about the CSA guide. Well, there was no CSA guide. We've talked about the BG coming out from BESA. Well, we do no BG in chemical-free cleaning. So, obviously, BG 29, 2021 is the guideline for pre-commissioning cleaning. So that was obviously a starting point. How do we maintain that but still use chemical-free? And we then looked into the VDI 2035 once we had translated it from German and brought in the parameters on that. Built a method statement up along with Reigate, Alexian and Briggs & Forrester. Put that to Chesterfield's, put that to the consultants, and everybody bought into the process, which was good after a bit of time. We then were at the stage where we're ready to fill systems. Reigate had built this fill rig, which you see in the kind of bottom picture there, which consisted of 2 essentially fill units from Alexian that were demineralisation, also did a bit of pH control in there and conductivity control. Now, the UV filter and copper silver anode, that was probably me that made them put that in. Now, that was my nervousness around about bacteria, because that seemed to be always a thing that screwed us up, as Chris has talked about as well, on systems. That TBCs, the pseudomonads, the levels, trying to get it down, the nitrate, the eating, it gets worse. So my concern was around about incoming water. As much as we were testing that to the BG guides for fill, I wanted to make sure we were trying to do as much as we can to alleviate any bacteria. Simon from Alexian pretty much told me, look, it won't be a problem, but he did it just to maybe pacify me. We used the closed-loop cleaning method, which is obviously, from a point of view, we're filling the system once, which is obviously a priority. We're using the filters to clean the system up rather than water in and water out. But it was a traditional backflush. So that was maybe something in my mind. I was expecting we're not going to put any water in and out of this system. But when we're doing the backflush at the terminals, we used a traditional, basically, used a fill unit to keep filling the system. But basically, we did a traditional flush out into a bin, as usual, and down the drain. And that's something we're looking at going forward. How do we alleviate doing the backflush a different way? There was also in the system, there's a reactor tank, which we got up and run as quickly as possible. And you saw that in Chris's slide with the magnesium and the anodes. And that is essentially what's conditioning your water. So our experience, so right at the very start of this journey, and when we were doing it, we'd filled the system, pressure tested it, we started the flush process, we went through the filters, and we were really getting some good water quality results in there, which was, great, it was excellent. We did then start to experience some problems with TVCs, and I'll come to that slightly later in my next part. And at that point in time, we put a UV filter on the system as well to try and clean that up. Again, Simon from Alexian would tell you the science and getting the pH level basically will get rid of your bugs in the system as well. But again, me, a bit of a panic merchant, I wasn't quite going to settle for that, so we put a UV filter on it. We also had a bit of an issue trying to get the dissolved oxygen down. Now, that was probably due to us maybe, again, not understanding the whole process of the system. So as a construction company, risk is always at the top of our agenda, and it's risk in all sorts, whether it's health and safety, but fire and water. Two things that are going to screw us up as a construction company, a project, is floods, which we've had before. To a point, one job I thought I could have kayak down the stairwell with that much water coming down it. And fire, there are two things we're trying to minimise. And what we say at the end of the job, the end of the working day, all pumps switched off, all water isolated, don't circulate, don't put any water. So if there's going to be a leak, we're not just putting water back in when the leak's coming out. But what issue we had is to get rid of the dissolved oxygen, you need to be going through that reactor tank. You need to be going through that continually to keep conditioning the water. And every time we're turning it off, we're only having 8 hours of circulation. And therefore, we're not getting through the tank enough and not getting the levels down as quickly as we want it. Because again, construction, it's all about time. It's all about starting that flush and finishing that flush, commissioning, BMS commissioning, handover. It's all about that. So we basically implemented a full circulation with the pumps. We also pH level again, and that was part of the same thing. Not enough circulation. The pH, we weren't getting that pH creeping up fast enough. But then, again, putting the pumps onto a continuous 24-hour run kind of sorted that out for us. So overall, it was a good experience. We learned an awful lot along the way. We continued post-handover to give good water quality. The bit with the TVCs was, we were at a point where we're actually looking at implementing, putting a biocide in there. We were very, very staunch against that. We wanted to be as chemical-free as we possibly could. But we did decide what way we were going to put in. Again, the science from Simon was, let the pH creep up and it'll take care of itself. And in fairness to him, it actually did. So challenges and lessons learned. So the dissolved oxygen, that was a challenge. Part of the challenge with that was probably the way they were measuring it. We were measuring samples. We were taking sample bottles. We were putting water in the sample bottle. There's been a pen stick. We'll send off to the labs. But at that point in time, you're essentially probably oxygenating the water again. So what we've looking at is real-time monitoring, and that goes for the dissolved oxygen and also pH, something we can see all the time. So our projects going forward, we've implemented basically real-time monitoring. So we've got a monitoring station that's monitoring the oxygen, the conductivity, and the pH level in the system, so we can see that. We don't need to be draining water off to see particular things like dissolved oxygen. And that's really made a big difference. We are finding it difficult, we found it difficult in that to achieve the 0.1 milligrams per litre. I think if you look at the 65 Davy Street job, we probably got it down to about 0.5 by the time we were handing over the job. But I think going after that, we continue going through that reactor unit at basically cleaned up. So that's one thing that we're looking at in our jobs we're doing now, is what level we put in there for dissolved oxygen, and we're speaking to many of the specialists about that. And 0.1 is quite difficult during that small construction phase to hit. We did also a bit of sampling frequency. With the new method, we had Chesterfield's taking a sample, we had Reigate taking a sample, they were doing them every week. But by that, we're actually dropping that water, good water out the system and topping up with other water, although it was going through a fill unit. It's not the best, because you're draining water out the system. So that's something we're kind of saying, look, if Chesterfield's or any validation engineer wants to take it, they come and take that sample with our engineers. We stick to the BGE guidelines for sampling, and we'll use some of the real-time monitoring to give us that daily update of how we're going with cleaning and flushing. I think the process, it took slightly longer than traditional, and everyone's saying to me, not so much Alexei and Reigate, but my team were all going, well, it must be quicker because we're not doing a chemical clean. You go, well, that makes sense, but you're actually, by using a reactor tank, you're still going through a process of cleaning and polishing up the system, so it doesn't take any quicker, and I'd actually argue probably takes slightly longer, not a huge amount. Using the fill rigs can still take the same time, but it probably takes slightly longer just to get your parameters into place, and think about that when you're looking at your commissioning and particularly your pre-com cleaning programs. Commence it as early as possible. Get systems finished early, because in any commissioning program or construction project, the single longest string is your closed water systems. To start filling, testing, pre-com cleaning, to commission and get out the other end. So starting them as quickly as possible, get the reactor tank on, get the system conditioning up as quickly as possible, and keep that going. You've got a bit of leeway in there when you're getting through the job. And as I said before, keep the pumps running. If you need to put a night watchman on, you need to put a security guard that's checking these systems, 3 times a night or whatever else, that's what we're doing so that we can keep the pumps running, keep conditioning the system and polishing it up. So what's next with Multiplex? So we essentially are promoting this in all our projects. So we roughly work on about 15 live projects any one time. 65 Davy Street is probably one of the kind of smaller projects we do. We're now implementing it on some of the other ones, Holborn Viaduct, Elephant and Castle down town centre stuff. And we'll look at it in the bigger jobs. We're looking at some big towers just now, Blackfriars, places like that. And we're looking to promote that and do this on those bigger jobs as well. So we've got 5 currently underway. We're still learning. We're still probably educating a bit of the water treatment companies as well. When I would look at this first with Ashford's, they were a bit kind of, I'm not sure. They're now involved in a job. Reigate are working a job for us. We've got Pro Technical in another job. We're helped out by guys from Alexei and IWTM with equipment and new technologies coming for us. So the more we do this, the more it's helping us, but the more hopefully it's promoting the industry. And it's good to hear, with the CSCA providing a guideline, the TM20, it gets out there, and also with hopefully the up-and-coming BG guideline from BESA as well. It gets it more out in the open, and people then say it is a thing that we are doing in the UK, not just something that specific contractors looking at as a wee niche or innovation. So I think it's been worked well for us. The results we're getting in Elephant and Castle just now are quite good going forward, and we'll keep doing it, and we'll keep looking at the innovations in water treatment to move it forward. Thank you.
Brilliant, thank you, David. That was awesome. And number 60, Holborn Viaduct, is that left, bottom left? Number 60. Yeah, it's my old job. So if it's all wrong, I'm not to blame. Up next, we've got Paul McSoley, who's going to give us a bit of technical expertise and what we should be doing and shouldn't be doing.
Well, the great thing is, Neil, I knew I'd get the little bit of time at the bottom, and because people in the audience like Will knows I can talk too much. So, Will, I'm going to save your ears today. I've got to find the clicker, because we've only got until 1:45, haven't we? So I'm going to be really quick here, right? So, I'm going to do it with edutainment, right? Okay, so the biggest thing is for me is, obviously, I don't do what these guys do. I deal with it with different clients. So it comes to me as an engineer working for my own business. But understanding the type of system, the extent of the buildings, this all goes back to the fundamentals of design. And I'm sure, David, you would agree with this, is that if you're going to do this, make sure you understand the materials and the fundamentals of design before you choose it, yeah? That's the main thing. Don't let someone go away and go, I'm going to use some, some plastic pipe work here, some stainless steel there, because it's going to end up, I think, on your slide, Chris, with a bit of steel that's left getting eaten to shreds. So understanding materials, the appropriateness of it, temperature, thermal insulants, and I think Chris Ridge is in the room, but obviously things like corrosion on the external side of pipework is just as important as inside of it as well, because if you get water under insulation, you will get corrosion. Understanding the pressurisation and the system pressure breaks. And I think you said it there really well, David, is that don't fill this stuff up with a Cat 5 system. not a good idea, Yeah, I've seen this. You get a lovely system, brilliant, and you go, what's it fed up from? Cat 5 system, great. Been sitting there for months in a closed leg system, no good. So just remember, make sure that the pressure's right. It all comes down to pressurisation. I think we've recommended previously with in some of the BISRA guides that just have one person doing pressurisation. Don't leave it to chance with loads of people. Get one person to do it, because otherwise you'll end up with loads of air valves sucking air in when you switch pumps off because no one's done it properly. It's a big problem. So what I'm trying to say is don't forget the fundamentals about Ollie the oxygen module and the cooler, because he wants to get in and have a good fun, bit of fun inside your system. So design review for chemical free early on. Make sure you get those things kind of closed out. And obviously, this is generated in AI. So you went to the one this morning. You can generate in AI, just don't be clever with it. Do you mean? Invent a character and follow it through. But obviously, oxygen likes steel pipework. That's the biggest thing as well. The type of material, don't have something that lets oxygen in. And again, there's a bit of, I can never say that word, Neil. You have to say, certain ones I can't say, that is one of them. BPDM versus the other one, I can't say that word, never comes out right. But make sure you've got your membranes right, because one's better than the other. Again, outside risk is equally important, like your vapor seals in your pipe, what I said earlier. I'm going to fly through because I haven't got a lot of time. Pressurisation is the number one oxygen risk in my experience. I've done jobs down near King's Cross where I've had to gone to the roof of a client who's got all the radiators and a plastic system are corroding, and I've gone up to the top, unscrewed the air valve, he's run, and I'm looking down, the water falling out the AHU cooled down the riser. Pressurisation's completely wrong. All that air's just going in, and the only bit of steel in the system was the radiators and the pressurisation in buffer tanks, and they've been eaten to shreds. So like things like ensure when your pump's stopping fire, you've maintained your pressure. You still got to get that bit right. That's what was happening there as the pumps were going off, just sucking it all back in. Because obviously you just don't want this guy getting at the pipe. You're going to get as much of it out as you can. Don't let your air in through your AAVs. Again, you can use corrosion probes. And it's amazing what AI generates when you ask it to produce something. It's good, isn't it? Do you know what I mean? So it's quite good fun. The other one, he actually should have been outside the glass, but I just gave up in the end. But you can see it now. I've shown it. You can see it, can't you? It should have been on the outside. But hey ho, it happens. Again, practical placement, cold feed dash, the pressurisation unit, high points. Make sure you look at this stuff early on in your review. Don't get it wrong, because you'll be looking at the wrong parts of the system, And think about your system pressure breaks, as I said earlier. Might have different things because we're all on heat pumps and things now with different pressure breaks. Make sure you consider all of it. And again, make-up meters. Don't have a water fun park where this guy comes running in with his friends. As soon as you fill it back up again, as you said earlier, Dave. You've got things like your BMS alarms, trend water loss to prevent or hidden oxygen loading. And that's the biggest one. You can have situations where you've got certain pieces of equipment letting water by and you're filling it up. And if you don't monitor it, all you're doing is, that's what's happening, isn't it, David? So, and it's funny you said about the Cat 5 and the TVCs. It happens all the time. Again, beware your Cat 5 fills. Some of this stuff is really basic, but you can go to the point of going for one of these systems and forget the basics, materials, fill points, persistent pressure breaks. It's very easy to do it. And again, the other one as well is about connecting new sections. If you've got this system and someone's going to come in and connect the system, make sure you've got a process for it. And I'm sure you would have come across that, Dave, as well. Because it does take a bit of time for it to get to that level of pH. And again, just avoid dumping dirty oxygen water into a stable system. That's the biggest thing. Think about in use, you've got to have a method to stop these guys getting at it, so they just can't get back in. And again, switching from chemical dosing, set expectations. It won't fix historic, as you said earlier, because they actually took all my thunder away, so I can go through this quicker. It won't fix systems that are in a really bad state. You just will not do it. And again, fix leaks, pressurisation first. Decide between full renewal versus progressive improvement. That's when it comes to changing over. And again, just as a really, really summation of it, just keep the oxygen out, keep the water clean, ensure your pH control is correct and monitored, control connections, maintenance, replacements, monitor the water in, good pressurisation. In a nutshell, a bit of AI. Thanks, everyone.
Right, thank you very much, Paul. Yes, we are jumping along a little bit quick here, but we are running out of time because there's the closing session later, so we'll get kicked out of here very shortly. So yes, further reference and guidance, the CSA has got TM20 out. Just go to the CSA's website, get hold of us via the office email, and we'll send it out for you. Distance learning courses, we have a full series of distance learning courses for commissioning and water treatment, but also we have a dedicated module now for chemical-free water treatment distance learning course for the water treatment engineers. And that's the reason why we did TM20, to give the engineers some guidance to follow, because we were getting asked that a lot. Well, you've got a training course, but where's the actual guidance? So that's why we did that. And this is all aligned to skill card, and going back to competence and what's been talked about today. Back to competence, you should be asking for CSA registered water treatment engineers. Have you got a grade 4 water treatment engineer on site who knows his stuff, who's done this training? So that's the next step. A few panel Q&As. We don't want to do too many. I'll just pick one out, I think. Chris, sorry. We've probably covered that. What's the biggest misconception, I think, for the panel on chemical-free water treatment and in the industry right now?
Hello, yeah, shall I have a go with that one?
Yeah.
There's obviously a debate whether chemical-free is the correct term for it, and I think that is, you know, when you talk to water treatment specialists, especially the ones that are pure chemists, they will say, well, it's not chemical-free. You are using chemicals to generate deeming water, and you are chemically adjusting the water quality. So I think that to me is the biggest misunderstanding about it. What we're talking about is an alternative approach from the use of what have been more traditional nitrite molybdate-based corrosion inhibitors and chemical scale prevention methods. That's really what we're talking about here, I would say.
I have looked at this a number of times and used AI to go, well, what do we call it? If it's not chemical-free water treatment, what do we actually call it? Demineralised water treatment, but it can be so many things. It's trying to capture that. Yeah, something to think about, something to take away for us. We are literally running out of time, so I'm going to skip a couple of the panel questions and go to the audience. Have you got any questions from the audience? Chris? Brian, sorry. I don't know why I keep calling you Chris. We call you Chris for forever.
Brian Hughes, Director of Dairy Building Services. I'm advocating this within our business, and we've only used it so far on copper and stainless systems. I'd like to know, on carbon steel, is this as effective or is this a no-no?
Certainly, the 65 Davis Street project was, I'm going to say, probably 70% carbon steel. We had copper runouts to fan coils, but essentially the main system was carbon steel, you know, and it cleaned up, to my surprise, very good, very quickly, I suppose, and, you know, without using the chemicals, so yeah.
Just to add to that, I think the biggest thing is, and good to see you, mate, because I've got the light in my eye, people are waving at me, and I'm like, I can't see you. Can't see you, sorry. Obviously, don't have situations I've had in the past where you go into a plant room, you swim through the pipework in the corner without the caps on it and come out the door the other room with a carbon steel, because it's not going to work, is it? I think all the traditional things, I mean, we've spoken about this, haven't we? Things like storage, good practice in the material handling, it all still is prevalent, if not as equally as important as it is in a chemically clean system.
The point is that obviously stains and copper systems are virtually clean anyway, and you don't get flash corrosion. Yeah. Obviously with carbon steel, you're going to get flash corrosion as soon as you start filling the systems.
But I think that's your filling with demin water, and it's conditioned water, so it's slightly more forgiving filling it as well. So you don't quite get that flash corrosion in the same manner. But as I say, our experience so far on that, the carbon steel has been relatively pain-free.
Thank you. One more question from the audience. Anybody else? Here we go. Thank you. You can say your name and which company you're from, please.
Jessica, Director of Richmond Hydrochem. I just wondered, obviously, when we have the new BISRIA guide for this, will there be a table like there is the table 4 at the moment? Will there be different parameters, obviously? Because we won't be looking for inhibitor and things like that. Will there be parameters that we'll be looking for after it's had no chemical treatment?
Yeah, yes. We will have a new table in there, and it will be called Table 4. Oh, can I say that, Chris? All right.
There will be
Surely it'll have to be table 4 part 2.
Yeah.
There will be an equivalent sort of a table to table 4 and 5 from BG 29, and they will be hopefully in line with what you see in other European guidance. Yeah.
Can I just say my only worry is that obviously once buildings are handed over and then people take over for maintenance, say we're a water treatment company and we go in, and when a lot of the facilities people won't necessarily know it's chemical free or it's not had inhibitor, and we'll go in and we'll go, yeah, you've got no inhibitor protection in that.
So
but we just put in inhibitor. That is my worry, to be honest. But
that's something we thought about, and that's why at the time, when we are going to contracts and with clients, we are, before we decide we are doing this, we get their buy-in, including their maintenance contractor. And we do, obviously at the end, you're doing client training, that type of thing, the O&Ms, it's telling them all that, but it's something we really have played heavily on, letting them know, look, you can't treat this the same way as you would a normal system, you know.
a lot of things like cars, people are going to have to just become aware of it, aren't they?
Can I just add to that? I mean, look, not to be rude, you get some clients that I think are quite intelligent and some that aren't so intelligent. And I think in contractual terms, because I deal with this element as well for other things, is that I think we have to be very careful. We're looking at this as probably tier 1 contractors. Hope you agree with that because it's on my striking range here. Is that if you take a job on with a client and you suggest something which you know they're not going to do it in the chemical free way, I think that probably comes sometimes into your thought. It should come into our thought process. Do you know what I mean? So there's that part to it as well. Do you know what I mean? Not to be rude, because I think both methods work, but one, if you take the average maintenance person, maybe, not to be rude, it might be that that client, you may go, this is in my mind, not to speak for you guys, obviously, because I'm in striking distance, but it may be that there's a balanced approach to be taken there.
Brilliant, thank you.
Thank you.
Right, unfortunately, we have run out of time. Some key takeaways there for you, and again, thank you for attending. Let's think beyond chemicals, protect the systems by design out corrosion, not fighting it later. Design, again, keep the oxygen out, as Paul said, and everybody said, control the pH, let the clean water do the actual work. Again, build it right from the design through to operation, keep the systems sealed, keep the systems clean, keep smart. Sustainability, it's going to produce less waste, fewer chemicals, longer lasting systems. A big thing for me I've seen on some of the existing buildings where I've seen this come in is the maintenance teams have actually gone, this is so much easier. I just need to now look at a little gauge on the front of this bit of kit and it goes, yeah, I'm all right or I'm not. It's more, they don't have to start taking loads of samples. They don't have to start taking water out. So once they get the mindset into it, it is better for the building, especially if they have a water loss or something like that as well. And like we've been talking about all day, innovation, responsibility, competence, compliance starts with us guys. So we're the guys to set this off on the right journey and make sure the buildings get handed over and the FM teams know about it's a chemical-free system. So again, thank you very much for attending. And I think this is for the next slide, is it?